Something fun going on with Unicode and Python requests. Firstly, note that u\xc3\xa8 is the Python 2 Unicode string with 2 code points, a, and. Next, note that \xc3\xa8 is the Python 2 byte str, which represents the UTF-8 encoding of the character a. So u\xc3\xa8 and \xc3\xa8, despite looking very similar, are two very different beasts. Now, if we try accessing https://www.sainsburys.co. In a browser, all should go well. If I define an Ipython session, then I can print it and see the same thing I entered into the URL bar of the browser. Great. Let's try and fetch this with Python requests. First, I naively just try throwing the Unicode URL to see if requests can just deal with it. Requests.get, Unicode_URL. Nope, 404, okay, no problem, URL should be encoded, so I try requests.get, Unicode_URL.encode, UTF-8. Nope, 404 again. No problem, maybe I need to do the URL encoding too, so I try requests.get, urlib.quote, Unicode_URL.encode, UTF-8, it doesn't like that at all. However, recalling the similarities between the Unicode and byte str objects I mentioned at the start, I also tried. And to my surprise, it works and gives a successful 200. What is going on here with requests? Edit, just as another experiment, in a scrapie shell this time. Absolutely no problems. So why do scrapie and the browser deal with it without issue, but not Python requests? And why does the alternate URL work in Python requests but not the browser or scrapie? Latin 1 versus UTF-8. It's also true that in general, I believe it's true that for Latin Unicode chars only, if you have a Unicode str like u\xc8, then you can convert it to a byte str of the same form by encoding to Latin 1, i.e. ue equals u\xc8 and u\xc8.encode, Latin 1, equals \xc8, the object on the right being a byte str encoding in Latin 1 with the same form as the Unicode code point representing the a. So, and similarly, I wonder if the culprit is from request/models.py.
The matter is that the URL on the site actually uses Latin 1 encoding for representing the a character, and for some reason, the Python 2 request library, in its attempt to clean up the URL automatically before making the call, encodes the a character in UTF-8. That is what causes the 404 error. Trying to encode the Unicode_URL in Latin 1 before calling requests.get does not help either. It attempts to decode that to Unicode before its clean up, and then errors on the invalid UTF-8 sequence that is the code for a when using Latin 1, the \xc8 char. At this point is worth noting that requests with Python 3 also works with no problem at all. As the language automates text handling, requests needs less dancing back and forth the text encoding, and on my first attempt on Python 3 I just got Now, I work around with Python 2.7 and request since had to come by, without monkey patching some specific code in request so that it does the right thing. However, even in Python 2, using your Unicode_URL manually encoded into Latin 1 and using alib.open instead of requests also work. If you really need Python 2, maybe that is the best approach for you. Really, if this is just some script you are doing for some particular tooling, I'd advise just to switch to Python 3.6. It will be a lot easier to handle the data when you get to it as well.
I observed something odd. Seems to work in a session the second time around. Possibly can say this is actually about cookies. The first request is without cookies and the web server 404s because of that whilst still setting some session cookies. The next request sends the cookies and the web server 200s. But, notice that the second request now does not need a redirect. You could replace the second request with s.get, unicode_url, allow_redirects equals false, and still get a 200, not a 302. Whereas the first request goes through a redirect chain. Hence the only reason it works now is that redirection is being sidestepped with cookies. This indicates the encoding issues are taking place somewhere in the redirect chain. Note, this is exactly the same as in a clean session of Chrome with cookies cleared. If you clear cookies then go to the URL, it will 404. If you re-enter it and try again, it will 200 with no problems. Cookies were set by your first request and the troublesome redirect that led to the 404 was avoided. There is one weird thing too. Despite no cookie sessions, I am struggling to understand that. The location header of the redirect in this case looks like i.e. we have the UT8 encoded UE instead of Latin 1 encoded. Summary. Given that the first request, the request that actually has no cookies and relies on redirects, fails in every platform I have tried, Chrome, Scrapey, Python requests, I would put this down to a bug on the host server itself. It Latin 1 encodes its location header in the redirect, but wants UT8 encoded URLs and 404s when the browser actually requests that redirect location URL, because the server was actually expecting a UT8 encoded URL. It should really be UT8 encoding the location header of its redirect response in order to be consistent with the URL encoding it is using. This is why when you cheat and use uhttp://www.sainsbury's.co. you actually end up with the correct UT8 encoded location header in the redirect, because uhttps://www.sainsbury's.co. .encode, Latin 1, is https://www.sainsbury's.co. which happens to be the correct UT8 encoded byte str of uhttps://www.sainsbury's.co. So when the browser redirects, it works. If you have cookies set from visiting the URL already or perhaps somewhere else on the website, you sidestep the need for a redirect and avoid the broken redirect process. See also, this URL, for how this works in Python 3 requests.